This is your homeboy, Mr. Sindel, coming back with another video live from LVHS. Lesson 1-2 today, limits to a point on a function. So, is that even the right name? Limits to a point on a function? Yes, on a function instead of a graph. Okay, so yesterday was all about graphs, seeing the visual representation of what's happening with our function. Today is purely saying no graphs. You get this function that says x cubed plus 5, and you need to figure out what's going on without a graph. That's the main thing that we're doing today. And you'll see that we have 9 lessons. This lesson goes super fast, so we have those lessons. Then we have self-check, unit 1 pretest, fix-up, test. Each of these is a day, so you know exactly when you're going to be doing the test if you plan that out, unless we have like a snow day or weird sports days, stuff like that. In terms of AP Calculus, even if all 3 of you gone, I will probably make a video and you will be required to watch it because the pacing for AP Calculus is intense. We cannot miss a day unless something crazy happens where you've been gone for a week and then we need a review. Maybe we can do a review date, but generally speaking, it's just every single day. I have it planned out to February. I know what we're going to be teaching every single day, theoretically. Snow days, again, just means you're going to be doing your lesson at home. So today, evaluating limits. So I did draw graphs for a lot of these problems so that we can connect yesterday's lesson to today's lesson, but this is the problem. F of x equals x plus 2, that's it. I need to know what happens, the limit of f of x as x approaches 1. I think I said that incorrectly yesterday. It's the limit of f of x as x approaches 1. Is that a double-sided limit, left-sided limit, right-sided limit? What type of limit is that one? Claire? Double-sided, why? There's no plus or minus. We always have to assume it's from the left and the right, which means the left and the right have to match up. If they go to different points, that's not okay. That would be a D and E. If they go to the same point, then we go to the height of that point. So what is it? Claire?
3.
It is 3. Let's go ahead and write down the answer. Let's talk about how Claire got that. Let's go back to the idea of a graph. When I go back to the idea of a graph, we can graph x plus 2. Do that now. Let me see that you know how to graph that algebra 1 function, that linear function. Show me that you know how to graph x plus 2. Claire has it.
Why is it wrong?
So far so good. You have 1 point. What's the x or the y-intercept here? There it is. And it looks like we're getting it. Okay, so everyone noticed that the x-intercept was 2. The slope of our linear function was 1 because there's a 1 in front of that x, an invisible 1, which means right 1, up 1, right 1, up 1. And you should have a few points like that. Obviously, that is going to be a line. Let's come here to my line tool. That line is going to look like this. All right, so now I'm saying what happens when I go to the x value of 1. When I go to the x value of 1 right here, what is the height? Well, from the left and the right, it has a height of 3. And that's where the 3 comes from. But Claire did that without visualizing the graph, unless you are actually really, really good at graphing in your head. You were able to do that without looking at the graph. Tell us what you did.
So, because the limit's 1 and it's x approaching 1, you just put 1 in for x and then solve the equation.
Yeah, and the keyword there, plug in. That's the keyword that I'm going to write down underneath here. Let's put a star on this. This is important. Plug in. This should always be your first step unless you're going to start skipping steps, which I know a lot of you are eventually going to start doing. This should be your first step. Whenever you do a limit, just plug it in. See if it works. Sometimes it won't work. Often for the AP Calculus test, it's not going to work because otherwise that would be too easy. All right. I need someone to read this. This is f of 1, but how do we say that? I came up with a way to say that yesterday. A word starting with h, the of 1. It's not f of 1, it's the height of 1. Say it louder. Height of 1. Proud. There it is. The height of 1, and we'll write it above here so we can remember that for our notes. The height at x equals 1. The height at x equals 1 also happens to be 3. Sometimes that's not the case, but I just want to get in the habit of saying f of 1 is really the height at 1. Let's try another one, again without graphing first, and it can't be Claire. She did her last one. It's going to be between Geo and Stego. What is the limit of g of x as x approaches 2? Trace. That was fast. It is indeed trace. Write it down. Now Geo is going to explain where 3 came from.
Same thing as the other graph. Just plug everything in.
So what are you plugging in?
Uh,
What number are you plugging in?
negative
So it has to do with this problem right here. Somewhere in here, what number am I plugging in? 2. And I plug 2 into this x, into that x, into that x. Where am I plugging in 2? Okay, so I have 2 squared, which is geo.
What?
2 squared. 2 squared. 2 times 2. There it is. All right, so I think we all understand how to get 3 now. Let's go ahead and do a quick graph of this. See if you know how to graph x squared minus 1. Just a quick review of, the end of algebra 1, the beginning of algebra 2, whatever you want to call that, a quadratic function. Show me that you know how to graph x squared minus 1. So the normal graph of x squared, don't write this down. The normal graph of x squared, if I didn't have minus 1, I'll do it in yellow, looks like this. It goes through the origin, right one, up one, and then it goes up odd numbers. So I went up 1, go up 3, up 1, up 3, or you can just think of it squared. 1 squared is 1, 2 squared is 4, 3 squared would come up to 9, way up there. That would be if I had x squared, but I'm doing x squared minus 1, so all of this gets shifted down 1. So this blue graph is the correct graph of x squared minus 1. It should be a curve, not a sharp corner there. It should be a nice, easy curve. If it was a sharp corner, that would be an absolute value, which you will have to solve in calculus as well. Less often, though. And then we can see what's happening visually. As I get closer and closer to 2, as I get closer and closer to this x-coordinate down here, this x-coordinate goes to this point. This point has a height of 3, That's where that limit came from. As I go closer from the left and closer from the right, I get closer and closer to 3. And therefore, this thing, how do I pronounce this thing? Quiet raised hand. Quiet raised hand. How do I pronounce g of 2 correctly? Quiet raised hand, g of 2, how do you pronounce that? It's very similar to the last one on the left. Claire? Height at x equals 2. There it is. And Claire, what is the height at x equals 2? 3. So these seem to be matching, which is a good sign. And this one will also match. And that seems kind of boring so far, but it will eventually not match, I promise. Ooh, a constant function. H of x is equal to 4. What is the limit for that guy? Again, you're plugging in. It's this key word down here is to plug in. I'm plugging in this number, negative 2. That's a little bit tricky here, though. So what is the answer to the limit of h of x as x approaches negative 2 from both sides? Negative 2. Anybody else? Claire? 4. Gio? Don't know. Okay. So if you would like, you can say 4 plus 0x, because 0 times anything is 0 and it's gone. So there's the x to plug in. Let's plug it in. So negative 2 is the number that I plug in. I'll plug that into that x. Negative 2 times 0 is 0. Plus 4 is 4, and Claire has it. It is going to be 4. General rule of thumb is if you can't plug it in, it's whatever number they gave you. So that constant function 4, if I can't plug anything in, it's just 4. Again, this idea of just plugging in. If I can't plug in, though, if that rule doesn't work, then it's whatever constant function that they gave me. And now the question, of course, is why? How does that connect to the graph? Try graphing h of x is equal to 4. What does that look like? That constant function. Again, an algebra 1 function. Let's see if we can do it. Claire has it correct. She has the first point correct. Steph is working on hers. So a good way to remember this one is for any value of x, again, you're adding that plus 0x. Any value of x, the height will be 4. So if I plug in 1, my output is 4. If I plug in 2, my output is 4. If I plug in 0, my output is 4. And eventually, with enough points, the pattern becomes pretty clear. Oh, it's just a horizontal line through 4. Of course, if you can just memorize that constant functions are horizontal lines, that also speeds up your process. And you can see here, as I get closer and closer to the x coordinate of -2 from the left and from the right, I get closer and closer to a height of, right there, the height of 4. So it makes sense in terms of our graph. All right, Gio, this one's yours. H of -2, how do I pronounce that? Yes, and the height at x equals -2 is what? There it is. Again, it matches up. Nothing too new. Questions up to this point? We're on to piecewise functions, and that means absolute value functions too, because absolute value are defined by piecewise functions. So, in this piecewise function, the way that I read this is this function j of x is equal to, well, when x is less than or equal to 1, this is the function, x plus 2. But when x is now bigger than 1, so I'm looking at 1, that's I call it my suspect point. It's just a word that I made up. There's no official term for it. I'm going to call it my suspect point. Can we all write that down? This is going to be called the suspect point. It'll be clear in a few lessons why I'm going to call that the suspect point. But my suspect point, something's going to change at 1. From the left-hand side, when I'm less than 1, when I'm left of my suspect point, I'm going to have this function x plus 2. But when I'm greater than 1, when I'm on the right-hand side of 1, so when I'm on the right of 1, I'm going to have this function, x squared minus 1. Oh, hey, those look really similar. X plus 2, x squared minus 1. We know how to graph both of those, but now we need to graph them both on this graph. Before I graph it, though, the whole idea is plug in. Again, that's always your first step. How do I plug in? Can someone read this to me? Is there a quiet raised hand that can read this to me? Limit of blah, 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 to blah, blah, blah. How do I read this question? This thing that I just circled. Go for it, Claire.
The limit of j of x is x approaches 1 from the left side.
Perfect. Oh, from the left side. Look, we wrote down from the left side. We must be plugging into this equation, specifically this x plus 2, not this x squared minus 1, because it said the left-hand side. This left matches with this left. We know this is left because it's to the left of 1. It's less than or equal to 1. By the way, in almost all of mathematics, especially on the AP test, I know 100% of the cases, the first line that they're going to give you in a piecewise is always going to be the left. So if you ever get confused, the first one is left. The last one is going to be right. Sometimes they do a middle point. They'll have 3 of them, and the middle one will be the actual height. So I'm plugging into this equation here. Claire got that step for us. Now I need someone between Stego and Gio. What am I plugging into x plus 2? 1. Gio, do it. Plug in 1. What do I get? 1 plus 2 is... There it is. When I plug in 1 to the left-hand side, 1 plus 2 is 3. It's that simple in terms of just plugging it in. All right, Stego, this one's going to be you. You need to read this.
I don't know how to read it.
Give it a shot. Make a mistake. That's how you learn.
Limit of j of x. I don't know.
As?
Limit as j of x.
No, you got it. Limit of j of x
Limit of j of x as x approaches to the right.
from the right. Perfect. From the right. Yeah. Okay, so Stego, which equation do you think you're going to be using? X plus 2 or x squared minus 1? Why?
It is from the right side.
It's that simple. All right. Claire, can you plug it in for us?
So 1 goes into x squared and then equals 0.
0. Okay. There it is. All we're doing is plugging in. And because Stego correctly said this is from the right, we're using the equation that says the right. Okay, before we even talk about the graph, now we're going down here. The limit, I don't want to pronounce this. I need you guys to practice. Who thinks they know how to pronounce this one correct? How to say it out loud? It's very similar to the last two. Claire, give it a shot.
Limit of j of x as x approaches 1.
As x approaches 1, and if you want to be pedantic, you don't have to say it. You can say as x approaches 1.
From both sides.
Exactly. This is the double-sided limit. All right. So this one is based off of these two answers. This is based on your homework as well. The answer here is what? There it is. Say it louder, Sego.
D and E.
There it is. Does not exist. If those two are different, this does not exist. And notice we haven't even touched the graph yet from yesterday. Ooh, okay. This one is going to be interesting, though. I want your thoughts on this last one. F of 1. I pronounce that as the height at x equals 1. What is that? And how do I get it? Claire has an idea. I'm going to wait for Stego and Gio to think. This is now equal to 1. At 1. Not the limit as I get closer and closer to that electric fence, but I'm actually going to touch and hold on to that electric fence. I am there. I am touching it. I am equal to it. Which equation am I plugging into? It's one or the other. I mean, you have a 50-50 shot if you just guess randomly. But I need the explanation as well. Stego, Gio, have an idea? The left.
Is the right side 0?
Good guess, but not quite. You are correct that it is the left, though. Claire, can you explain why it's the left?
So it's for the left side, it's x up less than and equal to 1, which means it includes the point 1. And when it's coming from the right, it's just x is bigger than 1, and so that means it goes up to the point directly after 1, but doesn't touch 1.
Yeah, and to simplify it, this has this little bar there, a little equal to sign. Since this is equal to 1, it's the height at 1. You're looking for the equal sign. There it is. Therefore, I'm using x plus 2. Good job, guys. All right, so I'm plugging in. Gio, you're going to do this for us. The height at 1, f of 1, is 3. There it is. All right, let's take a look at how that transfers to a graph. What would this look like if I were to give you a graph? Well, from the left of 1, it should look like x plus 2. I have that graph up here. I notice it has this x-intercept at -2, x-intercept at -2. It comes up, comes up, comes up, and it gets to this point. At 1, it is equal to that. So I can make a solid dot here. This is the most important dot that you're making. The most important dot is 1, 3. This is a solid dot. A filled dot. I have them up here too. It's a filled in dot. It is equal to at that point. And then at 1, at this x coordinate of 1, I now need to start this x squared minus 1, which does start down here at -1, and then it curves up through here. So I know it eventually does curve up. So it starts right here. So let me erase this guy. I have an open dot here at 1. It is not equal to it right there, but it does go to 2, 4. I should probably do this in a different color, otherwise it's going to get confusing. I do have an open dot here at 1, and then a solid dot here at 4, which is misleading because it looks like it's kind of completing the line. But this is going to be a curve as if it came up here, but that doesn't exist. And I do have this line that goes, let me try it again. One day I'll get up like this. Up, and it keeps going to the right forever and ever as well. So there's my line. So I have a blue line out here, and then it stops. It does equal to it at this point, and then I come down here, an open dot at 1 that comes over here for the orange. I did a dashed line over here that's not part of the graph, just to show you that is part of the quadratic function if I were to continue going to the left. All right, I threw a lot of stuff at you for piecewise limits. Ask questions. Take your time to catch up. Think about things. Digest the math.
What happens when it's a circle graph?
A circle graph. So that's going to be BC calculus, and we have to define that slightly differently. We have to define it either by, oh man, I'm forgetting the term, but when you either rotate using theta or by doing parametric equations where you say x is equal to something something t, y is equal to something something t. So parametric or the other one. We'll get that in like about a month is when we start on that, but for now we're not going to worry about it. No preguntas? Okay. And our last part of the notes, notice that the back is all blank. Your summary does go on the back. When plugging in fails, this will happen on the AP test 99% of the time. So if there's anything that I want you to learn, it's this. Because plugging in always is the first step, but they're going to make sure it doesn't work and make you work for that one point when plugging in fails. So let's try plugging it in. That is the first step. Let's do it. Let's plug in 2 to the equation. Well, when I plug in 2, I'm going to get 2 squared minus 4 times the quantity of 2 plus 4 on the top. And on the bottom, I'm going to get 2 squared minus 4, blah, blah, blah. Okay, let's see what happens. Let's continue this out. Well, 2 squared, that's going to be 4, minus 4 times 2, that's going to be 8, plus 4. Oh, I'm going to get 0. Okay, well, 2 squared, that's going to be 4. 4 minus 4, oh, that's 0. Whoa, 0 divided by 0. So I'm going to write this in green because you don't need it. If you want to know it, it's cool. It's called the indeterminate form. Indeterminate, I don't know if that's how you spell it, form. Whenever you get something like 0 divided by 0, or infinity divided by infinity, or infinity divided by 0, something like that. I don't know if infinity divided by 0 is technically part of indeterminate form, but definitely 0 divided by 0 is indeterminate form. It means that you failed at plugging in. You have to do something else. There's another method to finding that limit. Okay, there are 3 steps, and here they are. First step is to factor. Second step is to cancel. And the third step, you've already written it down, it's all the way back up here. Plug in again. Try again after you factored and canceled. So step 3 is to plug in. So I'm going to ask you tomorrow, what are the 3 steps when plugging in to a limit fails? I'm going to ask you in December, I'm going to ask you in May, and you're immediately going to be like, oh, factor, cancel, plug in. It's just something you have to have memorized for the rest of the year. Whenever plugging into a limit fails, 3 steps, factor, cancel, plug in. Repeat it after me. When plugging in fails, you, 1.
Factor, cancel, plug in.
Again, whenever plugging in fails, I.
Factor, cancel, plug in.
There it is. You're going to have to memorize that. And let's do those steps now. I'm going to factor. Well, this is based on Algebra 2 and Pre-Calc now. How do I factor the numerator? Anyone? Ninja Star. Yes, Claire has it.
I showed that to my German class, and my math teacher thought it was amazing.
It is pretty nice. Yeah, so Ninja Star, they probably, at least I know for Anya when she was teaching us, she's just said AB is equal to C, or like she just had a bunch of equations that she had to solve. Is that generally how they did it also? Or?
No, they just struggled for a day and a half trying to figure out.
Okay.
They were not good at math.
Let's do our Ninja Star off on the side. Ninja Star, and this one does not need to be an advanced Ninja Star, which has an additional line in the center because there's no coefficient that's like 2 or 3 in front of it. So just a normal Ninja Star. This middle term, -4, is going to go on the top or the bottom. It doesn't really matter. I think it normally goes on the bottom. And then you just put this number up here on the top. So this last number went on the top. This middle number went on the bottom. All right, the question is, what times what is 4, and what plus what is -4? So this is when you add, this is when you multiply. Negative dose, negative dose. There it is. So our new equation after using our Ninja Star is x minus 2 times the quantity of x minus 2. And you can also write this as x minus 2 quantity squared. But for now, I'm going to leave it x minus 2 times x minus 2. Questions on using the Ninja Star to factor the numerator. Again, strictly speaking, the Ninja Star is not math. It's a tool to help you factor, and factoring is very strictly math. It's a tool. It's a nice tool, a very nice tool. Questions, no questions. We're factoring the bottom. You can still use Ninja Star on the bottom. Should we try it? It looks weird because you're not having a trinomial, it's a binomial, but it still works. I'll do it in green. I ran out of room because I'm doing things too big, but here is my, I don't need to do advanced. Here's my Ninja Star. Ninja Star says I put the middle term, the coefficient in front of the x. Well, there is no coefficient underneath the x, so my term should be 0. Let's put 0 down here. Okay, and then the last number, this constant term, -4, that goes in the top, that's what they multiply to. So now the question is, what times what is -4, but they also have to add up to 0. Claire? -2 and 2. There it is. And then my answer is x minus 2, x plus 2. So let's write it down. X minus 2, x plus 2. We just did step 1, factor. You do need to have factoring mastered in order to be able to use a step, obviously. Questions about step 1? Questions about NinjaStar? Nothing? All right, step 2. What do we see? What do we cancel, Stego? X minus 2. We see 1 in the numerator, 1 in the denominator. Cross them off. They are gone. We just did step 2. That was easy. Geo, you are doing step 3. Read it off first of all. Step 3 is to plug in. And what am I plugging in, Geo? 2. Plug it in. And that is equal to what, Geo? 4? Like that? What's the numerator first, Geo? The denominator is? Therefore, 0 divided by 4 is? If I have 0 pieces of pizza and I'm going to divide them amongst 4 people, how many? Okay, there it is. 0. There it is. It's not indeterminate form because I'm not dividing by 0. That is a number, a natural number. 0. Well, some might argue that it's not natural, but most mathematicians will say it's natural. Done. That's it for the notes. Questions? All right.